Hello, we're going to continue on with SQL. Okay, so we can use an order by to order the display of tuples. So here, this lists the name of the instructor in alphabetical order. So it's going to be from A to Z. Now, if you want it in a descending order, you can simply add this keyword descending. Okay, so order by name, and then you have descending. So whatever you see in bold are going to be all keywords. So we're selecting distinct name from instructor order by name. So we have distinct here because if we didn't, all the duplicated names will be displayed. So you may see more than the same name twice. Okay, so if you want to get rid of those, you just use the word distinct. You can also use the keyword between to specify a range. So you could easily just do, select name from instructor where salary is greater than or equal to 90,000 and less than or equal to 100,000. Or you can, if this is, I think, is simpler, you can just do salary between 90,000 and 100,000. Okay, so these do the same thing. You could also do comparison like this, where you have select name and course ID from, and you're doing a Cartesian product between instructor and teaches. And then we have two parentheses here, and we have an equal sign in between. So this means that this is equivalent to having where instructor.id is equal to teachers.id and department name is equal to biology. So it really depends on whichever you prefer. I think this might actually, for me, it looks a little bit more confusing. I just prefer to have this is equal to this and this is equal to this. But if you have many different conditions with the equal sign, then this might be useful. Okay, we talked about set operations where whenever you see the keywords or, and, or but not in, we did this in relational algebra. Okay, so now we're doing it in SQL. Okay, so we're finding the courses that ran in fall 2017 or spring 2018. Okay, so the first subquery is going to return all of the course IDs from section where it was taught in fall of 2017. And then here we're using the keyword union for or. Okay, and then the last half is all the course IDs that were taught in spring of 2018. Okay, so the rest are the same other than the fact that because it's and, we're using the keyword intersect, okay, but not in, so we're using except. Okay, okay, so union, intersect, except, all of these will automatically eliminate duplicates. But if you do want to still see the duplicates, all you have to do is add the word all followed by union, intersect, or except. So you would just have union all, and this will actually return all of the duplicates as well. Okay, so it is possible for some of these tuples to have no value. The value is not really no, we don't know it. So we can just denote it using null. Okay, just missing information. Okay, so this signifies that it's an unknown value, or this value simply just does not exist. We don't have that information. Okay, so the result of any arithmetic expression involving null is null. So 5 plus null is null, 5 minus null is null. Anything involving null in this arithmetic expression will give you null. The predicates of null can be used to check any null values. Okay, so select name from instructor where salary and then the keyword is null. Okay, so this will find all of the instructors whose salary is not known or it's null. Okay, so we're using the keyword is null. Okay, the predicate is not null, so now we have not is not null keyword. Succeeds if the value of the value is no, not null. Okay, so if there is a value, then it's going to be returned. So is not null is the exact opposite of is null. Okay, so if there's a value, it's returned. Okay, so SQL treats as unknown the result of any comparison involving a null value. So let's take a look here. So other than the predicate is null and is not null. So we have 5 is less than null, or null is not equal to each other, or null is equal to equal null. So the predicate where clause can involve any Boolean expression involving and or not. Okay, so let's take a look at this using the value unknown. Okay, so true and unknown is unknown. Okay, because with and, both have to be true in order for this to be true, right? Is Okay, so they all have to be true. So true and unknown. So if this unknown is true, then this would be true. If unknown is false, this is false. So that's why true and unknown is unknown. Okay, the next one we have false and unknown. Okay, so as soon as there is a false, the whole thing becomes false. Okay, both have to be true for this whole thing to be true. But because this is already false, it doesn't matter what the value of unknown is. It's going to be false automatically because of this. Okay, same thing here, unknown and unknown. So that means it could be true and true, right? If it's true and true, it's going to be true. So unknown. It's false and false, it's false. So unknown and unknown is unknown. Now with or, only one of them has to be true. As long as at least one is true, the whole thing is true. So we have unknown or true is true. So it doesn't matter if this unknown is false or true, because we have a true in here with the or, this whole thing will be true. Unknown or false. So if this is true, the whole thing will be true, right? So if it's true, this is true. If this is false, then it's false. Okay, unknown or unknown. So if it's true or true, we have at least one true, so it's true. If it's false or false, since we don't have any true, that whole thing will be false. We talked about aggregate function in relational algebra, so it's going to be exactly the same function, the 5 functions. You have your average function, the minimum function, maximum function, sum, and then count. Count is counting how many number of values. Okay, so the first example we have here is we want to find the average salary of instructors in the computer science department. So in relational algebra, we had to use that kind of this G symbol, right? But here, there's not any of those. You have to use just the name of the function here, which is average. So select average, and then parentheses we have salary. So we're computing the average of the salary attributes from the instructor table, where department name is equal to computer science. Okay. Number 2, we want to find the total number of instructors who teach a course in the spring of 2018 semester. Okay, here, make sure that you are counting the distinct ID. Okay, so select count. We're counting how many numbers, and we're distinct ID from teaches, where semester is equal to spring and year is equal to 2018. If you did not have the distinct ID here, it's probably going to count the same professor's ID more than once, right? Which would not be accurate. It's not what we're looking for. We want distinct number of instructors. So make sure you have distinct here. A very common mistake not to have it. Find the number of tuples in the course relation. Okay, so select count and asterisk. So asterisk means everything, right? Okay, we're finding, how many rows of data we have from this course table. Okay, here is another example of using group by. So in relational algebra, in order for us to group by, whatever we're grouping by, for example, department name appeared first. So department name, and then we had the G symbol, and in parentheses, we had average salary. Okay, so here it's the keyword group by that you're going to be using. Okay, you can use group by only if you're using an aggregate function. So if you didn't have this, then group by, this will give you an error. It would not work. So these aggregate functions and group by kind of work together. Okay? So we're selecting the name of the department, comma, average of all the salary. Okay, if I didn't rename this as average salary, it would just say salary. Okay, so it's not really accurate. We want to, it's going to be the average salary. So we have renamed it using the keyword as from instructor, and then we're grouping by department name. Okay? So that means that we're computing the average salary of all instructors per department. Okay? So as you can see here, we have one biology, so the average salary of this person is just this, right? And we have 3 professors in the computer science department. We are taking the average of these 3 numbers, and this is what we got. Okay, we have 1 electrical engineering, so that's 80,000. Okay, the average of these two will give you 85,000 and so on. So by doing grouping by, group by, we are grouping these by this attribute department name and computing the average salary per department name. We also have select department name, ID, average salary from instructor group by department name. So when you just kind of look at this, you probably wouldn't notice, okay, this looks right. What's wrong with this, right? So whenever you are using group by, the only things that you can display are whatever you're grouping by, and then the aggregate function itself. Okay, so the ID here would not really work because, let's just take a look at this one, right? So if by adding ID as one of the attributes that we're displaying or selecting, okay, there are 3 different IDs from the computer science department, right? So here, if there was an ID here, which one are we displaying? There are 3 different numbers, right? So that's why it doesn't work. Whenever you're using an aggregate function along with the group by, the only things that you can display are whatever you're grouping by and the actual aggregate function. So this ID here will cause an error. You can also use group by with having. Okay, so here we have select department name, and then we're computing the salary from instructor, we're grouping by department, and then we have a keyword having. So we're going to do all this, but we only want to return the ones where average salary is greater than 42,000. Okay, so you can use having only if you're using group by. Okay, if you did not have group by here, this would cause an error. Okay? You can also have nested subqueries. Okay, so you can have a subquery in the select clause, you can have it in the where clause, and you can have it in the from clause as well. So here we're finding courses offered in fall of 2017 and in spring of 2018. Okay, so here we have select distinct course ID from section where semesters fall and year is 2017, and then we have a subquery here, right? So this first portion will list, it's going to return a bunch of course IDs that are offered in fall 2017. So it'll just be a bunch of course IDs, and then we have another condition and course ID in, and then we have a subquery. Okay? So this subquery will return all of the course IDs that are offered in spring of 2018. Okay, so if this course ID also appears in these list of course IDs, those will be returned. Okay, so that's why this will return all the courses offered in fall 2017 and spring of 2018. Okay, so this one is exactly the same as the previous one, but here we're using not in. Okay, so select distinct course ID from section, and then these are all the courses that are offered in fall of 2017. But then this course ID should not be in any of the courses that are offered in spring of 2018. So these are some keywords to kind of look at. So in and then not in, right? So this course ID should be in this list of course IDs that were returned by this subquery. Okay, this course ID should not be in any of the course IDs returned from this subquery. Okay, so this set membership. We want to name all instructors whose name is neither Mozart or nor Einstein. So we're doing select distinct name from instructor where name, so this name is not in, and then we have a set. Okay? So name should not be Mozart or Einstein. Okay, so that these are the lists that were returned. Okay? Find the total number of distinct students. So if you are looking at total number of something, that's going to be a count. Okay? Aggregate function count, distinct ID, who have taken course sections taught by the instructor with ID 10101, right? So we're selecting count distinct ID from takes where, so it's not just a single attribute here, but it's a combination of course ID with the section, with the semester and year in, and then we have a subquery. So make sure these match these. Okay, so we have course ID, section ID, semester and year, okay, from teaches where teaches that ID is 1011. So let's think about what this particular subquery down here returns. Okay, so this is going to return the course ID with the section, semester, and year of all the courses that were taught by the instructor whose ID is 1011, right? Okay, so that's why this should be in here. So this will return the total number of distinct students who have taken all the courses taught by, or have taken any course taught by this instructor. So we have a few exercises. We have done the same thing in relational algebra. Now we're doing them in SQL. Number 1, find the names of all employees in this database who live in the same city as the company for which they work for, ordered by the names of employees from Z to A. Number 2, find the names of all the managers who manage Calvin Harris, but not Martin Garrix. Okay, so let's go ahead and pause this video and work on these queries. And when you're done and ready, you can go ahead and hit play again. Okay, so here you notice how we're using order by. Okay? And it's not from A to Z, but it's from Z to A, so it's going to be in descending order. Okay, let's go over it. So we are selecting the names of employees, so that's going to be e-name. And let's think about which table we can find this information. Okay, so it talks about the employee and the city that they live in. Okay, that can only be found in employee, right? Employee city. The city as the company which they work for. So we also need to know the city that the company is located in, which is going to be company. So we need employee and company. Okay, we want to order by name of the employee. Okay. And we also care about which company they work for. So we will need this information from the works table. This particular employee works for this company. Okay, so we are doing a Cartesian product between employee, works, and company. We're selecting e-name. Okay, we want to, so these are Cartesian product. It's going to return every single combination, and that's not really useful unless we specify a condition. So in order for us to get some useful information, we want to set the e-name from employee equal to works.ename, and then c-name from works is equal to c-name from company. So those are the two conditions here, and then it says that same city as the company which they work for. So the employee city should equal to company.city. So that's what we have here. And then we are ordering by the name of the employees. So we are doing order by e-name. And since it's Z to A, we're doing descending order. Okay, so it was a little bit lengthy, but you will get used to it. It will get more complex than this. So these are just some keywords that you should remember. Order by descending. Okay, number 2, find the names of all managers who manage Calvin Harris but not Martin Garrix. So this is the keyword here, but not in or but not. So that's going to be keyword except. So the first subquery will return all the managers who's managing Calvin Harris. Okay, and then except but not. And then this one returns all the manager names who are managing Martin Garrix. Okay, number 3, find the names of all pairs of employees who are managed by the same manager. Okay, so these are two different employees, but they have the same manager. Okay, so their names, the employee names should not be the same, but their manager names should be the same. So whenever we're comparing like a pair, so it's two different employees, we want to make sure that we're doing a Cartesian product between employee and employee. And whenever you're doing a Cartesian product between the two or the same tables, you have to rename one to be called something else. Okay, number 4, we have the average salary of employees for each company whose average salary is greater than 70,000. Okay, so go ahead and hit pause, and you should be taking about 4 or 5 minutes per query. So whenever you're ready, we're gonna go over the answers. So number 3, we are doing a Cartesian product between managers and managers because this one has the name of the employee that's being managed by the manager, which is M name. So we have select, actually let's start from here. So from clause, we are doing a Cartesian product between managers and managers, and we are renaming them to be called P1 and P2. You could pick whatever name I want, but I just picked something shorter, P1 and P2. Okay? And then P1 ename is not equal to P2.ename, so we're making sure that we're not talking about the same employee. They're two distinct, two different employees. So their names are different, but their managers' names are the same, meaning they're being managed by the same manager. Okay, and we want to display the names of all pairs of employees, so we're displaying P1's ename and P2's ename. Okay, number 4, we are taking the average salary of employees, okay, for each company. So this is the keyword here for each company. This means that we're going to be grouping by this company. Okay, so this can be found in works. Okay? So select name of the company because we're grouping by that, right? So whatever you're grouping by, you want to make sure that you're displaying that. Okay, and then comma, we are using the aggregate function average of the salary. So if I didn't rename this as average salary, it would just say salary for the column name or the attribute name. Okay, and then from works, group by CNAME. And then we have this last condition here where the average salary is greater than 70,000. So I'm going to add that condition right here using the having keyword.